Let's get started with example 2. We'll start with my decision variables. It's a fixed charge problem, so I have two sets. My first decision is which warehouses to open. So I'm going to use a binary, 1 or 0. Just like that. My other decision is how many units to ship from each warehouse to each region. I'm going to use a matrix for my decision variables to illustrate this. We have some constraint about this. Each region has a required amount of shipments. This sentence tells me the requirements for each region. That's data I got from the problem, so I'll format it that way. I can find the total shipped to the region by summing the column. And that must equal 80. That's going to be the same for each region. Sum each region must equal the requirement. We also have a constraint about the warehouses. Each week, the warehouse can only ship 100 units. So I'm going to sum across each row for the warehouse. That must be less than or equal to 100 in the problem. Before I move on or format this as data, I'm going to use my linking constraint. If I choose not to open the New York warehouse, then this must be a 0. But if I decide to open the New York warehouse, then this can be 100. I can ship up to 100 units from New York if I open it. So this is where I link my maximum amount times the binary decision variable for that warehouse. And I'm going to do that for each warehouse. So that way, if I decide to open Atlanta, now I can ship up to 100 units from that location. Now let's fill in the rest of the constraints. If New York warehouse is open, then the LA must be opened. So if this is a 1, this must be a 1 here. However, this is also allowed. LA can be opened and not New York. So it's just a one-way constraint. The way I do this New York must be less than or equal to LA. That allows this scenario. LA can be open on its own. 0 is less than 1. It will not allow just New York to be open. This cell must be less than or equal to LA, so therefore it would force LA to be opened as well. At most, 2 warehouses can be open. This one's simpler. I'm going to sum up how many warehouses I'm opening. Must be less than or equal to 2. Finally, either Atlanta or the LA warehouse must be open, or both. So this must have a 1, or this must have a 1, or both of them. To ensure that, as a constraint, I equal the sum of the two, LA plus Atlanta, must be greater than or equal to 1. My objective is to minimize cost. I have 2 kinds of cost, fixed and variable. My fixed cost is a sum product of which warehouses I'm opening times their fixed cost. My total variable cost is a sum product of the number of units I'm shipping from each warehouse to each region times their costs. Total cost is then a sum of both components. Let's solve it. Here we have it. All constraints are satisfied. We have a minimum total cost of $4,750.